Yes, hello, welcome. Today we are going to be looking at the concepts of EMF, electromotive force, EMF, potential difference, PD, efficiency of a cell, and lost volts. So we are looking at four concepts in electricity today. Number one is electromotive force, EMF. Number two is potential difference. Number three is efficiency of the cell, and number four is lost volt. What is electromotive force, EMF? I told us in the previous class that electric current flows whenever there is supply of charges from a cell. Normally we call a cell battery. Without a battery, you cannot see what is supplying the charges. And when these charges that are supplied flow through the circuit, we have what we call electric current. For current to flow, there has to be a cell, there has to be a battery that supplies the charges. So the electromotive force, EMF of the cell supplying the charges. The electromotive force of a cell is the total energy generated per coulomb. It is the potential difference across the terminals of the cell in an open circuit, and it is measured in volts. So for the battery to supply the charges that will move as a current around the circuit, there has to be a cell. And what is the force in the cell that enables the charges to move? That force is known as electromotive force. So when you have a battery or a cell, the force that enables it to let the current or the electric charge to flow in the circuit is known as the word EMF. So this electromotive force is actually the energy generated per coulomb that enables charges to flow through a circuit, and it is measured in volts. Now we look at the concept of potential difference, PD. If the cell is not connected to other electrical instruments or electrical components, the potential difference across the circuit will just be the EMF of the cell. But once the circuit is connected with other things like resistors, capacitors, and other things, then we talk about potential difference. So potential difference, PD, is the work done in moving an electric charge from one point to another in a circuit. So for a circuit like this that has a resistor, for charges to move from one point of these are the terminals of the cell, for charges to move from here to here, there has to be what we call potential difference, which is the force that enables the charges to move. But for this one, this is another circuit. There is no resistor. It's just the cell itself. So for charges to move, there has to be a force, and that force is known as EMF. But if the circuit is connected with resistor and other electrical components, the force going is known as potential difference or terminal PD. So you can say that the electromotive force and potential difference are very similar. Just that this is done for an open circuit. Electromotive force is for an open circuit. That is a circuit that is not connected to any other electrical component. Whereas potential difference is the same energy, but this time connected to other electrical components like resistor. So this is also measured in volts. Potential difference is also measured in volts, and it is the energy or the work done in moving an electrical charge. So mathematically it can be represented as PD to be equal to energy obtained or energy over charge. Now we look at efficiency of a cell. How can you make your cell to be more efficient in order to supply enough force or energy that will transport the charges to generate the current? How can you do that? Number one, cells are made efficient if the internal resistance is low. you must make sure that the internal resistance inside the cell, is very low. Once it's low, it can enable much force that will push the charges round the circuit to enable an easy flow of current. Number 2 is that the electrodes or the plates of the cell have to have large surface area, and they have to be placed close to one another. Like now you can see the electrodes, the two of them, they have to have what we call large surface area, and they need to be placed closer to one another. So when you have a battery or a cell that has the plates have large surface area and they are placed closely to one another, they are going to have what we call higher efficiency. Now we look at a concept known as lost volt. What is lost volt? If you look at these two circuits, you see that this is a cell and it's not connected to any other, it's not connected to a resistor. This is a voltmeter measuring the EMF of this cell, which is the force that enables charges to move, the potential difference across the terminals of the cell. So this voltmeter is just measuring the voltage of this cell. Nothing else is connected. But if you look at this other circuit, the cell is connected to a resistor. So the voltmeter is measuring both the EMF, the difference between the EMF of the cell and the voltage that has been taken off by the resistor. So you can imagine the force here will be bigger than this because the resistor have already taken some force out from this because of the presence of the resistor here. But this one does not have any resistor. So what is the lost voltage or the lost volt? The lost volt is simply the voltage that is measured in this one that does not have resistor, represented as E, or you can call it the EMF of the cell, minus the voltage that is measured when a resistor is connected, represented as the terminal PD, V. So the difference between the voltage here and that measured here, the one measured here and the one measured here, is known as what? Lost volts. So when you are asked to explain the concept of lost volt, you should know that it is simply the voltage difference in the circuit that is made up of only the cell and the one that has a resistor connected to it. So the difference in the voltages that are measured gives you the lost volts of the cell. That is where we are going to stop for today. We've been able to explain 3 concepts. Electromotive force, like I told you, is the energy that is generated that enables charges to flow through the circuit, causing current. So that force, that energy is known as electromotive force, and that energy is coming from the cell. But when the cell is connected to other things, other electrical components like resistor, we talk about the potential difference between 2 points. You can see that is potential difference. So potential difference and electromotive force, both of them are measured in volts. It's just that this one measures for the cell in an open circuit, whereas this one measures across the whole circuit. Efficiency of a cell, like I told you, what supplies the charges that move through the circuit that causes electric current is the cell. For the cell to be very efficient, it has to have low internal resistance, and the surface area of the plates or the electrode has to be very large, and the electrodes or the plates have to be kept closer to one another. And I told us that lost voltage or lost volts is simply the difference in the voltages that is measured when the cell is not connected to any other appliance or any other electrical component, and the one when the cell is connected to a resistor. So if you take the voltage here, E, which is the electromotive force, minus the voltage across the circuit when a resistor is connected, V, the difference between these two, this one minus this one, gives you the lost volts of the cell.